Okay, ladies and gentlemen, now we're going to look at example 6, which is writing real-life problems based on the graph shown. So let's take a look at this example. It says, write a real-life problem that will fit the data shown in each graph. Is the domain of each function discrete or continuous? So we can start by looking at this first graph here, and just looking at it, you'll notice that each point is by itself. There's no line connecting them. So you can ask yourself, is this discrete or continuous? And right away you should be able to tell this is discrete because there are specific points. On this graph, if you'll notice, the line continues straight down. Therefore, is this graph discrete or continuous? Well, it involves all of the points that lie between 6 here and going down to 0 on the y-axis, and from 0 to 6 here. So this is a continuous graph. So that's going to show some differences when we start to write the domain and the range. Now let's try to think of a real-life problem. They want to have a real-life problem to explain this data that's shown. So now let's take a look at letter A. And what do you notice about each point? Well, this point is 0, 6. This point is 1, 5. This is 2, 4. Sorry. This is 3, 3. And 4, 2, and 5, 1, and finally 6, 0. So what can you notice about each of these points? Well, if you look at them closely, you'll see that the sum of them is always going to equal 6. The sum of the x plus the y is always equal to 6 in this problem. And the value of each variable has to be a whole number from 0 to 6. So we can't have pieces of things, right? Because it's discrete. So let's think about two people that are bidding against each other on 6 different coins at an auction. So if we had 6 different coins and we bid, each coin would be purchased by one of those two people. Because it's not possible to purchase a coin, the domain is discrete, a part of a coin. Or you could think of anything that does not have parts of things. So you can just think of like, so if X doesn't get any of the coins, but Y does, X plus Y is going to equal 6. So if the one person gets 1 coin and the other person gets the 5 other coins, then that's the 6 total coins. So that's the kind of idea here. In part B, if we look at a real life example, now there's 2 variables, an x and a y, and it's continuous, okay? Now, if you look at this, the sum of the variables is always 6, and the value is always going to be any real number from 0 to 6. So now a continuous problem to match this one would be 2 people that bid against each other on, let's say, 6 ounces of gold dust. Okay, because you can have parts of gold dust, and so all the gold dust has to be purchased by those 2 people. So because you can purchase parts of it. So that's an example using the same type of coin thing, but again, it could be any type of a real life situation where it involves pieces, okay? So that's like the idea with writing real life problems to match the graph. At this time, please complete monitoring progress problems that are attached in the document in Google Classroom. Thank you.